Hey guys, and welcome back to the 6th episode of the Magic Shooter tutorial. In this episode, we're going to set up the attacks on the player side and finally get to kill some enemy. The first thing we want to make is another data structure. This will be a data structure for the player to keep track of its attack and information. Like last time, we can create a new script and remove the mono behavior because it's a data structure, as well as include system.serializable at the top. We have a number of editor variables that we want to have. The first is a string for the name of the attack. This is important because we also want to use this later on, so we're going to put a public getter function called attack name. We also want to specify which input is going to be used to trigger this attack. This will have to reflect the name of a button in input settings, otherwise you'll get an error. Again, we want a public getter function, so we'll set that up as well. We also want a name that will specify the trigger that will be used to call the animation later on, so we'll set the string for this, as well as another public getter function. The animation and triggers will be covered more next episode, so don't worry about it too much for now. Continuing on with our editor variables, we want a variable m_ability_go for the prefab game object of our attack that we'll instantiate. If you remember, when we instantiate an object, it will be given a position to spawn in. So we'll need a vector3 variable for the position, or the offset from the player that the attack will spawn in at, so it doesn't pop up right in the center of the player. As with many games, our attacks will have a windup time, a cooldown time, and a period of time where the player is frozen while attacking. So we'll need 3 floats for these: m_windup time, m_frozen time, and m_cooldown. Windup time and frozen time will have public getter functions, but not cooldown. We'll be setting cooldown separately, so we'll be making a public function in the public functions region that will have a public get and set function. Okay, last 2 variables. The first one is how much health the player will lose when attacking, since that's the mechanic of how attacking works. Again, it needs a public getter function. The second is the color that we want to associate with the attack. We'll be changing the player's mesh to match this in the next episode. We have a few functions that we also want to set up for the cooldown. Since we'll be actively counting down the public cooldown variable, we'll have a function to reset the variable by calling cooldown is equal to m_cooldown. The last thing we'll be writing is a way to check if the player should be allowed to attack, is ready. This will return a boolean that checks if the cooldown timer has been run all the way through. And that's it for the data structure. I know it was a lot of variables, but it'll make our lives a lot easier when we're setting everything up. Now, in PlayerController, we want to add an editor variable to set up an array of PlayerAttackInfo objects so that we can add attacks in the editor. In the private variables, we want to add a float to keep track of the time that the player will be frozen in place while attacking. We want to be able to check that the player can move around otherwise. We want to initialize the frozen timer to 0 so that we can start the game moving. So in awake, set p_frozen time to 0. We also want to iterate through the list of attacks and set them equal to 0 so that they can be used immediately. We want to add an additional check here. Since we can put any numbers into attack_info data structure, we want to make sure that these times are reasonable. This is a useful check when working with other people to make sure the scripts are used properly. This also helps to prevent typos from creating massive bugs. So if the windup time is longer than the frozen time, we'll call an error in the console. We'll call debug.logerror to register an error and provide the text of attack.attackName has a windup time that is larger than the amount of time the player is frozen for. So if this does happen, there will be an error that will pop up in the Unity console. The check we'll be doing with frozen timer will be at the very beginning of the update function. If the frozen timer is greater than 0, then we'll set the player velocity to 0 so that the player doesn't slide around, and then we decrement the timer. Then we'll return so that the rest of update doesn't get run. Otherwise, we'll set the frozen timer back to 0. Now, we want some way to actually call these attacks and use them. If you remember, we have the use functions in the laser attack scripts that were inherited from the ability abstract class. You may also recall that we have a bunch of timers that we want to wait out for our windup time and cooldown. We could do what we've done before with subtracting time.delta time from a float. There's a much better way to wait for time to pass: coroutines. Coroutines are a special type of function that run independently of frames and can pause its execution, which makes it perfect for when we need a timer, like now. We'll create a new attack methods region and create a coroutine. There's some special syntax that goes along with coroutines. One of them is that the function will return an IEnumerator object. This is a C# iterator over a collection of objects. If you're interested in how IEnumerators and coroutines work together, I'll put links in the description since that's beyond the scope of this project and the class. We'll be passing in the PlayerAttackInfo object into this function. The first thing we want to do is reset the player position so that we're facing directly where the camera's facing, so that we're attacking forwards. Next, we'll wait for the windup time. To wait, we're going to return a new wait for seconds object. The way that returning works in coroutines is that it temporarily gives control of the function back to Unity, where Unity will wait until some condition is met before allowing the coroutine to continue running. So we're going to yield a return to a new wait for seconds object that will wait for however long the attack.windup time is. This will correspond with the time it takes for the animation to run, but we'll deal with that next episode. Once that amount of time has been passed, the coroutine will continue to run. Now, we want to instantiate the actual attack. First, we'll finalize the offset of the spawn position of the attack. We'll basically make a new vector that combines the offset and the position of the player with respect to its own position. Next, we'll want to instantiate the laser attack, passing in the spawn position as a transform position plus the offset, and giving it the player's current rotation as its angle. If we set a variable to the return value of instantiate, we can reference the object afterwards. Here, we want to get the ability component and use run, and pass in the offsetted spawn position. Then, we'll wait for the cooldown timer with another wait for seconds yield return. After that time passes, we'll reset the cooldown timer so that the attack can be used again. And that's it for the use attack coroutine. Next, we want to write the code for calling these functions. In update, we'll iterate through each attack and check if they're ready to be used. We have a function made especially for this, isReady, which returns a bool based on whether or not the cooldown timer is run down. If that is satisfied, we want to check if the corresponding button is being pressed for that attack. If it is, then we want to set the frozen time to the respective frozen time of the attack, and we want to call the useAttack coroutine. To call the coroutine, use the function startCoroutine and pass in the coroutine including parameters that we want to be run. Since we only want one attack at a time, we'll break the for loop if an attack has been used. Outside of the attack.isReady check, we want to decrease the cooldown timer, so we'll decrease it by time.delta time. Now, we're finally ready to test this out. On the PlayerController component, you'll see an attacks drop-down section. This will resize based on the size of the array. We can put in 2 since we have 2 attacks. The first one will be called Laser, which will be on the Fire 1 button, which is the left mouse button. The trigger name will be Shoot Laser, and we can drag the laser prefab into the ability game object. We'll be replacing the model for the player in the next episode, so the offset will change, but for now, we can set the offset to be at 0.5, negative 0.25, and 1. The windup time is going to be 1, the frozen time 2.3, the cooldown time 2, and health cost will be 1. As for the color, let's set it to a nice magenta color. The exact values of the color are R253, G46, B219 on the RGB 0 to 255 scale. Likewise, we'll set the variables for the second laser. The name is Mega Laser, the button will be on Fire 2, which is the right mouse button. The trigger name is Shoot Mega Laser, and we can drag the Mega Laser prefab into the script. The offset is going to be 0.5, negative 0.35, and 1. Windup time is 1.5, frozen time is 2.3, cooldown time is 2.5, and the health cost is 1. The color for this one will be red at R243, G41, B41. Now let's finally test this. If you click, you can shoot lasers from the player capsule, and if you hit an enemy, the enemy will die. The player can finally fend for itself. This concludes setting up all the attacks and abilities for this tutorial. We've created a pretty flexible system for creating and organizing our attacks, and setting up different variables that we need for our attacks. Next episode, we'll start making the game look much better by adding some models and animations in the game. Thanks for watching, and I'll see you in the next part.